Right, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today I will do a recording lecture on a continuous probability distribution. So this continuous probability distribution is basically the concept is still same as a discrete probability distribution. We just change the variable to become a continuous variable. Right, so instead of using a discrete random variable, now we are using a continuous random variable. So introduction. So a random variable, right now let me use this one. Random variable x is said to be continuous if its set of possible value is entire interval of number. Means that um, there are no value like discrete random variable. So means that in continuous random variable, the value of x is available any number between negative infinity to infinity. It means that it has a 1.52. It doesn't work like discrete distribution. Means that discrete distribution we have 1, 2, 3. Between 1 and 2 there are no number for discrete random variable, but for continuous random variable, so between 1 and 2 there are numbers between 1 and 2. Means that there between 1 and 2 entire value between 1 and 2 are possible. So means that for the same a less than b, any number x between a and b are possible. So the definition, so a function with fx probability of x defined on over the set of all real number called as probability density function instead of probability distribution function for discrete random variable. In the continuous random variable, we call as a probability density function. So of a variable x, if and only if probability of x between a and b, right, is equal to integration from a to b with a function of probability density function with respect to x. So for any constant a and b, and a is smaller than b, means that the a is smaller than b, so b should be upper limit lah, right? So if you recall, if you want to find probability in discrete random variable, let's say you want to find probability of a between probability of x between a and b in discrete random variable, we just did what we do is we summarize, we sum from a to b probability of x, right? So we will get the probability of x between a and b. But for continuous random variable, we do a different way, which is we need to do integration for continuous random variable, right? So in continuous random variable, we are looking into the area under the curve, right? The area under the curve that give the probabilities associated with the corresponding interval along the horizontal axis. Means that when we are looking into area under the curve, so there are no point probability. Means that if in a discrete random variable, if you want to find probability of x equal to 5, what we need to do is we need to find probability of x equal to 5, right? So but in continuous random variable, if you want to find probability of x equal to 5, means that there are no point probability, right? If you want to find a probability for continuous random variable, right, we need to find within the range, so we can find the area under the curve. If you want to find the point probability, it should be equal to 0. So any value, any point probability, let's say we want to find probability of a is a constant, any constant, so it should always equal to 0. So the probability of under continuous random variable, it should be find within a range, right? Between a range, because we want to find the area under the curve. So if you want to find area under the curve, then we easy to do integration, right? So important notes, let x be a constant. The value of probability density of x at C does not give the probability of x equal to C as in discrete cases, like as I said before. So the probability of x equal to C always equal to 0 for any real constant C. Right. So let's look at theorem number 1. Right. If you still remember, don't look at this one first. So let's recall the discrete random variable. If you want to find probability of A, probability of x between A and B, means that A inclusive, B also inclusive, means that we want to find probability of x equal to A plus until probability of x equal to B. Right, means that let's say this is 4 and this is 6, so means that we want to find probability of x equal to 4 plus probability of x equal to 5 plus probability of x equal to 6. If you want to find probability of x between 4 and 6, means that 4 is not inclusive, probability of x equal to 5 plus probability of x equal to 6, right? This is how it works in a discrete random variable. Let's say another one is probability of x equal to 4 between x and 6, means that 6 is not inclusive, 4 is also not inclusive, means that we want to find probability of x equal to 5 only. So this is for discrete random variable, right? For a continuous random variable, it doesn't care with the equality sign, right? If you want to find probability of x between A and B, whether x is inclusive or not inclusive, right, is always same, because we want to find the area under curve, right? This one also same, this one also, this one and this one, means that if you want to do integration, then we will take the value of A until B with respect to dx, right? So now let's look at theorem number 2. The theorem number 2 for a continuous random variable is always follows the rule of probabilities, means that for any value of x should always between 0 and 1, right? It cannot be exceed 1, it cannot less than 0, right? For any value of x, where x is from negative infinity to infinity, then the integration of fx from negative infinity to infinity, right, means that with respect to x is always equal to 1. If you still remember, in a discrete random variable, the summation of all value of x should always equal to 1. This is work for discrete random variable. So this is for continuous random variable. Right, let's look at the example. Now, given the following function x, so we have 3x squared for x is between 0 and 1, right? This is the function. So we want to show, the first question is, show that fx can serve as probability density function of x. So in order fx to serve as a probability distribution function, the integration from negative infinity to infinity with respect to x should equal to 1. So here the negative infinity to infinity is a symbolic function, is a symbolic number, means that from the lowest value, the lowest possible value in x range, and then infinity means that the largest or maximum value in range of x, right? This is the lowest possible. So in here, in this example, the lowest value is 0 and the largest value is 1. So if you want to find whether fx can serve as a probability distribution function, so we need to do integration, right? This is for number 1. We need to integrate from 0 to 1 3x square with respect to x. So I hope you still remember how to do integration. So this one should be 3x power of 3 divided by 3 from 0 to 1. So this one should be x power of 3. So this is 1 power of 3 minus 0 power of 3 should be equal to 1. So since the integration from 0 to 1 is equal to 1, so we can say that fx can serve as a probability density function of x. Right now, for B, we want to calculate the probability of x between 0.1 and 0.5. So to integrate to find this probability, then we need to integrate from 0.1 to 0.5. So this one is 3x square with respect to x. So this one is x power of 3 from 0.1 to 0.5. Divide by 3, we already right, we already omit 3, right? So this one should be equal to 0.5 power of 3 minus 0.1 power of 3. So this one should be equal to 0.124, right? Okay, right. So let's look at another example, right? Example number 2. So let me make some space here. Right. So in this example number 2, let random variable z represent the weekly demand for soft drinks, right, in thousands liters, right, at a certain mart of in Sandakan. The probability density function of a random variable z is shown as below. So this is a probability density function. So we have z squared multiplied with 2z plus 3 over 2. For the z value is between 0 and 1. So find the probability that weekly demand for soft drink between 200 liters and 600 liters. So this is 1,000 liters, means that from 0 to 1,000. So we want to find the probability from 200 liters to 600 liters. So for A, we need to do integration from 0.2 to 0.6. So z square multiply with 2z plus 3 over 2 with respect to z, right? So this one should become, if we can do a simplification, right? This is from 0.2 to 0.6. This is 2z power of 3 plus 3z square over 2 with respect to z, right? So this one should be equal to, if you do integration, so 2z power of 4 divided by 4 plus 3z power of 3 divided by 6, means that 3 multiplied with 2 equal to 6, and this is 0.2 and 0.6. Right, so this one should be, if you expand this one, let me put underneath of the equation, right? You may use another color. So this one should be equal to 2 multiplied with 0.6 power of 4 divided by 4 plus 3 multiplied with 0.6 power of 3 divided by 6, right? And then this is minus with 2 multiplied with 0.2 power of 4 divided by 4 and plus with 3 multiplied with 0.2 power of 3 divided by 6. If you do simply you solve it by using a calculator, you will get 0.17067, right? So this is the value of probability. And then if you can we set in our class for value of probability, we will set to up to 4 decimal point, right? So this one, it should be 0.1707, right? We will round it to 4 decimal point. So now the second question is, they ask us to find the expected of 5z square minus z plus 3. So in order to find the expected value, so if you still remember, the expected function still remains same as a discrete distribution. For discrete linear variable, what we do is, if you want to find expected of x, so we will do summation of x multiplied with probability of x. But for this is for a discrete, right, a random variable. For a continuous random variable, if you want to find expected of x, it should be integration x multiplied with fx with respect to x. Let's say we want to find expected of x square, it should be the integration of x square multiplied with fx with respect to x. So if you notice that if you want to find the expected value of x square, any value under the bracket of expected, so it should be multiplied with the probability function, right? So it's the same. If you want to find probability of x square plus 2x, it should be equal to the integration of x square plus 2x multiplied with fx, right, with respect to x. So and the properties of expected also remain. If you want to find 2x square plus 2x minus 2 or plus 2, it should be expected 2 multiplied with expected of x square plus 2 expected of x, right, and plus 2, right? If you want to find minus, you just put minus here. So this is the rule of expectation for discrete and continuous random variable. It's still same. Instead of for random variable, discrete random variable, instead we are using for discrete random variable, we are using summation. For continuous random variable, instead of using summation, then we use integration function, right? So now back to the question, right? So the question is, the question is, we want to find the expected of z square, right? So B is, we want to find the expected of z square, 5z square minus z plus 3. So what we can do here, if we are using properties of expectation, so we will get 5 multiplied with expected of z square minus, right, minus expected of z plus 3, right? So this is what we will get if we are using the properties of expectation. So now first we want to find the expected of z first. To find the expected of z, we need to integrate from 0 to 1, z multiply with fz with respect to z, right? So the function of z is z square. So we take this one lah. So this is already simplified the function, 2z power of 3, right? So we going to integrate from 0 to 1, z multiply with 2z power of 3 plus 3z power of 2 divided by 2, right, with respect to z. So if you simplify this one, right, it should be from 0 to 1, 2z power of 4 plus 3z power of 3 divided by 2 with respect to z, right? So there is a simplest way, right? Instead of you do a manual calculation, right, for manual integration, so you can input this value inside the calculator, right? Your calculator, so you will get 31 over 40, right? So another function which is expected of z square should be equal to integration from 0 to 1 z square multiply with fz with respect to z. So this one should be z power of 2 to z power of 3 plus 3z power of 2 divided by 2, right, with respect to z. So this one should be equal to, from 0 to 1, this is 2z power of 5, means that we need to plus this one, plus, and this is 3z power of 4 divided by 2, with respect to z, and this one should be equal to 19 over 30. So now we can use the expectation formula. So we want to find 5z square. 5z square minus z plus 3, is it? Yup. So this one should be equal to 5 multiplied with 19 over 30 plus, and also not plus, it should be minus, right? Minus 31 over 40 plus 3. So this one should be equal to 5.391667. So it becomes 5.3917, right? Alright, so let's look at another example. So example number 3. So in example number 3, the total numbers, the total number of hours measured in unit of 10 that a student spend on doing revision before sitting for examination is a continuous random variable y with a density function. So here we have two density function, y squared from 0 to 1, m minus y is from 1 to 2. So the first question is we want to find the value of m. Right, to find the value of m, we need to apply the rule of probability. Means that the integration from negative infinity to infinity should be equal to 1. For that situation, right, for the lowest value is 0 and the largest value is 2. So what we need to do is, for number 1, we need to do integration from 0 to 1, y squared with respect to y, plus integration from 1 to 2, m minus y with respect to y equal to 1. Right, so then we do an integration. So y power of 3 divided by 3, this is from 0 to 1, plus this is my minus y squared over 2. This is from 1 to 2 is equal to 1. So let me bring this one to here. So this one should be 1 over 3 minus 0, right? This is plus. This is the first part. This is for the first part. For the second part is 2m minus 4 over 2. This is for the first part, right, of the second part, minus m minus 1 over 2, right? So this is equal to 1. So now let me simplify this one. This one should be 2m minus m is equal to 1m. So 4 over 2 minus 1 over 2 plus 1 over 2, it should be 3 over 2, right? Negative 3 over 2. So this one should be 1 over 3 plus m minus 3 over 2 equal to 1. So we can do a simplification for constants. So m minus 3 over 2 plus 1 over 3 equal to 1. This is m minus 7 over 6 equal to 1. Then m is equal to 1 plus 7 over 6. So m is equal to 13 over 6, or equal to 2.167, right? So we can input m value in the function. So y squared is from 0 to 1, and 13 over 6 minus y is from 1 until 2, right? So this is how we solve the problem. Next is we want to find the probability that a student will spend less than 15 hours on the revision. So it means that for number 2, we want to find the student will spend less than 15 hours. 15 hours is this number is multiplied with 10. So 15 hours should lies between is here lah, 1.5 until 0. So what we need to do is we want to find the probability of y less than 1.5. It should be equal to from 0 to 1 y squared with respect to y plus, and this is from 1 until 1.5. So this is 13 over 6 minus y with respect to y. So this one should be equal to 19 over 24. You can solve it manually. So next, the third question is we want to calculate the average number of hours that student will spend on the revision. So expected of y. So we want to find the average. Average means that the expected of y, which is equal to mu, right? So expected of y is from y multiplied with y squared with respect to y. This is from 0 to 1. And then another one is y multiplied with 13 over 6, right, minus y, right, with respect to y. This is from 1 until 2. So this one should be equal to 7 over 6, right? This is how we solve the problem for when we have a two density function in one function, right? Okay, let's look at the last example, which is example number 4, before we enter into a cumulative distribution function, right? Okay, for example number 4, suppose that a random variable x has a continuous distribution with the probability density function given by x is between 0 and 1, 2 minus x between 1 and 2. So we want to find probability of x between 1 and 1.8. So this is basically same step as previous example. I just want to make you to understand. So we want to find the probability of x between 1 and 1.8. So we will integrate. So 1 is basically here, and 1.8 is basically still between this value, right? So 1 and 1.8 is lies under this range, right? Not under this range. So we will use this function only. So from 1 until 1.8. So let me make it my integration symbol nice. So oops, not still not nice. So whatever you draw, or how you draw the integration symbol, make sure we understand this is integration. So from 1 until 1.8. So this is 2 minus x with respect to x. So this one should be 2x minus x squared over 2 from 1 until 1.8. So this one should be 2 multiplied 1.8 minus 1.8 square over 2, and minus 2 multiplied with 1 minus 1 over 2. So this one should be 12 over 25. So which is equal to 0.48, right? Okay. So next step is we want to calculate the expected value of 2x plus 3, right? To find the probability of expected value of 2x plus 3, expected of 2x plus 3, it should be equal to 2 multiplied with expected of x plus 3. So now we need to find probability of x, expected of x. So expected of x should be integration of x multiplied with x with respect to x. So this is for the first function, right? For the first function, okay. And then we need to plus integration from 1 to 2 x multiplied with 2 minus x with respect to x. So this one should be equal to 1. So then if you want to find this value, so 2 multiplied with 1 plus 3 should be equal to 5, right? So this is for this upon continuous density function, continuous probability distribution function. So let's look at the next topic under continuous distribution function, random variable, right? So cumulative function for continuous random variable. So if you still remember in discrete random variable, if you want to do a cumulative distribution, means that we will add from the lowest value to the largest value. We add all probability function together, right? So the symbol for continuous cumulative function is capital Fx, right? Capital F. And for cumulative distribution of continuous random variable x with the probability distribution of fx is defined by every number x by probability of fx is less than of x, which is we will integrate from negative infinity until x, where we replace the probability density function with the t variable, and we integrate with respect to t, and then we will get the x value lah. And then we put x is equal to t is the value of probability distribution of x at t. Is called a distribution function or cumulative distribution of x, right? So let's look at the example, nanti kita tengok. So instead of we find the area and the curve for this is for discrete continuous distribution function. or we call as a probability distribution function. So we want to find area under curve. When we have a cumulative distribution function, so the function will be shown as S-shaped distribution, means that it will do a summation from the lowest to the largest, right? So this is a cumulative distribution function. So now let's look at the theorem. Let x be the continuous random variable with a probability density function fx and the cumulative distribution function of capital Fx for any real value a and b, where a is smaller than b. So if you want to find the probability of x between more than a, means that we just need to find 1 minus fa, right? This is for a cumulative continuous distribution function. If we want to find probability of a between probability of x between a and b, we just need to find cumulative of b minus cumulative of a, right? So this is very simple if you are using a cumulative distribution function, right? So now, some important notes, right, for obtaining fx from cumulative distribution. From, if you still remember, in discrete random variable, if you want to obtain probability distribution function from a cumulative distribution function, we just need to take a subtraction, means that we subtract for the largest value minus the smallest value, right? So for continuous random variable, since if you want to find a cumulative distribution we need to do integration from negative infinity to x with respect to t, right, dt. Right. So since we can do integration by the theorem of calculus, right? When we can do integration, we can also do a derivative, right? We can find a derivative where if the derivative exists. If you want to find the probability distribution function or probability density function, right? We can do a differentiation of cumulative distribution function with respect to x, right? So this is the whatever when we can do integration, we also can do a differentiation, right? Now let's look at example number 5. So in example number 5, the probability density function for continuous random variable x is given as x 2x 2 minus x. This is from the previous example. Now we want to find the cumulative distribution function. So to find the cumulative distribution function, so since we have two functions here, so if you still remember in discrete random variable, we will do for continuous random variable, for cumulative distribution function, we will start from 0 and we will end at 1, right? Cumulative distribution function will start at 0 and end with 1. So we will do the same things, right? So cumulative distribution function, we will start from 0, where 0, the range of 0 is x less than 0, means that this is the smallest value for x as less than 0. So to find the first cumulative function fx, we need to integrate from 0 to x. Whereas now here x, here we will change it to t with respect to t, right? So when we do integration, we will get t squared over 2 from 0 to x. So this one should be equal to x power of 2 divided by 2. So this function will be x power of 2 divided by 2 from 0 to 1, right? For the second function, right, since the cumulative distribution function means that we will add the first function to the second function to the third function to the last function. Alright, so this one should be from 0 to 1. So if you remember the function, the theorem means says that when we want to find the probability distribution, cumulative distribution function, we will integrate from negative infinity to x, right? So what we will do here is we will integrate from the negative infinity from the smallest value to x. So this is going to be x. So x with respect to, so this one we will change x to t, right? Instead of using x, we are using t. T with respect t plus from 1 until x. So you can see the difference of the range that I take into the integration. 2 minus t with respect to t. So this one should be t squared over 2 from 0 to 1 plus 2t minus t squared over 2 from 1 until x. So this one should be equal to 2x minus x squared over 2 minus 1. So how I get this? So it's very simple. You just plug in the value into the formula. So let me show you how I get this, right? So this one should be this is 1 over 2 minus 0, right, plus, and this is going to be the first one 2x minus x squared over 2 minus 2 minus 1 over 2, and this one should be equal to if you manage this one minus and with this one should be 2x minus x squared over 2, and this is going to be minus 2 plus 1 over 2, minus and minus is equal to plus, and plus 1 over 2. So that's why it become, this is become 1 minus 2 minus plus 1 is equal to 1x minus x squared over 2 plus minus 1. So here it should be equal to 2x minus x squared over 2 minus 1. So this is from 1 until 2, and the last value is 1 where x is more than 2. So this is a cumulative distribution function for x. So to find the second question, to find probability of x between 0.8 and 1.2. So since we already have the cumulative distribution function, what we need to do is cumulative of 1.2 minus cumulative of 0.8. So cumulative of 1.2 is lies in this range, and 0.8 is lies in this range. So we just need to apply the function, which is 2 multiplied with 1.2, which is this one, right, minus 1.2 squared over 2 minus 1 minus, and x squared over 2, this is 1.8, should be this one. So 0.8 squared over 2. So we just plug in the value, we will get the value, which is 0.36. Okay, let's look at another example for cumulative distribution function, right? Let me make some space here. Okay, now in this function they give us the distribution function already. They give us the cumulative distribution function, which is capital Fx for random variable x. So it start from 0. For 0 is x is less than 0 and negative 1. X plus 1 divided by 2 is from negative 1 to 1. So now we want to find the probability of x between -1 and -half and half. So -half is still here, -half is here, and half also here. So what we need to do is we're going to apply the theorem 1 over 2 minus f -1 over 2. We just plug in the value. So 1 over 2 plus 1 divided by 2, and minus, this is the first part. The second part is -1 over 2 minus 1 divided by 2. So this is plus 1, right? Plus 1 divided by 2. So this one should be equal to 0.5. So every value just insert into this function. So the next question is we want to find a probability density function. To find a probability density function, when we can do integration, we also can do a derivative, right? Where if the derivative exists, right? So we will do a derivative d with respect to dx for x plus 1 divided by 2, and then we will get so if you do we separate the value, so with respect to x, x over 2 plus dx 1 over 2. So this is having no constant, this is having no variable, so this is going to be 0. Then this is going to be x. So 1 minus 1, so it should be equal to 0, right? Equal to 0. And then this is going to be 1 over 2, right? Right. Oops. Sorry, this is not equal to 0. It means that it's actually x power of 0 means equal to 1, right? So let me clear this one first. X, this is basically initially is power of 1. So 1 minus 1 should be equal to x power of 0 divided by 2. So x power of 0 is equal to 1 over 2. Right? So this is the probability density function will be fx equal to from 1 over, so it should be equal to 1 over 2 for x from -1 to 1. So this is 0 elsewhere. Okay? Alright, let's look at another example, right? Which is example number 7. So the probability density function, this is the probability density function of a continuous random variable x, is given as c minus 2 or 0.2x from x is 0 until 2. And the second function is 3 for x is between 2 and 3. So we want to find the value of c. So to find value of c is quite simple. By applying the rule of probability means that the integration, right, this is for 1, the integration from -infinity to infinity should be equal to 1. For this case is the integration from 0 to 2 c minus 0.2x with respect to x plus the integration from 2 until 3 for 3 with respect to x is equal to 1. So we do integration here. It should be cx minus 0.2 x power of 2 divided by 2. So this is from 0 to 2 plus 3x from 2 until 3. So this is equal to 1. So let me put here. This one should be, if you do integration, then this one should be, the first one is 2x 2c, sorry, 2c 2c for the first one, 2c minus 0.2 multiplied with 2 power of 2 divided by 2. So this is for the first part. For the second part is 0, right? 0 means that everything multiplied with 0 is 0. So this second part is 0. So plus the second one is 3 multiplied with 3 minus 3 multiplied with 2 equal to 1. So if you can do a simplification, this one should be 2c minus 0.4 plus 3 equal to 1. So 2c plus 2.6 equal to 1. And this one 2c should be equal to negative 1.6. C is equal to negative 0.8. So I think you need to recheck again. I think if I do a mistake in plug in the value, so you can inform me in chat room comment section, right? Right. For this one, for at this stage, I just leave it at this one 0.8. If I do a mistake, so please inform me. So this one is fx is equal to negative 0.8x minus 0.2x. This is from 0 to 2. And the second one is 3. Oops. I just plug in the value of c lah. Huh? 3 is 2x until 3 and 0 is elsewhere. Right, so this is the function. Next, we want to find the expected value of x. So to find the expected value of x, right, expected value of x, we need to integrate from this is the function, right, negative 0.8, right, x, so this is no x, right, 0.8, right, negative 0.8 minus 0.2x. So we need to multiply with x if you want to find the expected value of x. So this one should be from 0 to 2. So 0.8x minus 0.2x squared with respect to x, and plus, and 3x from 2 until 3 with respect to x. So this one should be equal to 161 over 30 is equal to 5.3607. Right. Next step is we want to find the expected of 7 plus 2x. Is it? So to find the expected of 7 plus 2x, so this is based on the value what I found in C. So if the value of C is wrong, so if I input the value, so you need to calculate again. If I wrongly input the value of C, so the value of fx and the next value is also wrong lah. But you got the idea, right? So we just need to find the C value. So this is going to be 7 plus 2 multiplied with the expected of x. So we also already know the value of expected of x. So 7 plus 2161 over 30. So this one should be 266.1 over 15. Right. Next question is we want to find the cumulative distribution function. For cumulative distribution function, we want to find fx. So fx, let me put here so we can see clearly, right? Fx should start from 0, right? For x is less than how much? What is the x less than 0 lah? Less than 0. So we will solve for the first one from 0 to x for negative 0.8 minus 0.2 t with respect to t. So this one should be negative 0.8 t minus 0.2 t squared over 2 from 0 to x. So this one should be equal to negative 0.8 x minus 0.2 x square over 2, right? So this is going to be 0.1 lah, right? So this one should be negative 0.8x minus 0.1 x square. So this is from 0 to 0 to 2, right? For the second part, for the second part, right? For the second part, fx should be equal to the integration from 0 to 2 negative 0.8 minus 0.2 t with respect t, and this is from 2 until x, is it? 2 until x, and this is 3 with respect to t, right? So this one should be equal to negative 2 plus 3x, right? So we just plug in the value negative 2 plus 3x. This is from 2 until 3, and last one is 1, which is x is more than 3. So this is the cumulative distribution function for x. Okay, now let's look at the last example. So this is quite heavy example. We need to do a very detailed calculation, right? So this example, the probability density function for continuous random variable x is given as k x minus 1 for x is between 1 and 3. Another one is k multiplied with 7 minus x for x is between 5 and 7. So we need to show that k is equal to 1 over 4. So let me do it in below section. So by employing the rule of probability, so first is from 1 until 3, kx minus k. So I just input multiply k and x, k and 1 with respect to x plus, and this is 5 until 7. So 7k minus xk, right, with respect to x is equal to 1. So we integrate this one, should be k x power of 2 divided by 2 minus kx from 1 until 3, and this is 7 kx minus kx power of 2 divided by 2, and this is from 5 until 7. This is equal to 1. Right, so we input the value. This is you need to be very careful here. So 9k divided by 2, this is the first part. 9k divided by 2 minus 3k, so this is the first part, minus k over 2 minus k, and this is the second part. For the second part, the second half of the equation, so 49k minus 14 minus 49 k over 2 minus 35k minus 25k over 2, and this is equal to 1. So we do a simplification, 9k over 2 for this first part, so minus k over 2 minus 3k plus k, right, plus 49k minus 35k minus 49k over 2 minus a plus negative plus 25k over 2. This is equal to 1. So the first part we will get 8k over 2 minus 2k. The second part we will get 14k. This one 14k minus 24 k over 2, right, equal to 1. And this is 4k minus 2k plus 14k minus 12k equal to 1. So 2k here, and this one also 2k equal to 1. So 4k equal to 1. So then k is equal to 1 over 4, shown as the question asked lah. Right, for the second question, right, they ask us to find probability of x between 2 and 3. So this is going to be very simple, right? Integration 2 and 3 is basically lies under 2 and 3 is lies under here. So it should be from 2 until 3, x minus 1 over 4. So remember, k is equal to 1 over 4. So x over 4 with respect to x. So this one should be equal to 0.375. And the next one is we want to find the cumulative distribution function. Right, cumulative distribution function. Let me write here, down here. For cumulative distribution function x, it should start from 0 to 1. So for 0 is the lowest value is x less than 1, right? So first step is we want to find the first value, which is we're going to integrate from 1 until x for t minus 1 over 4 with respect to t. So this one should be equal to, if you do integration, t over 2 over, so let me take out the value of 1 over 4. So 1 over 4 here, integrate from 1 until x. So this is t minus 1 with respect to t, right? So this one should be equal to 1 over 4 t over 2 over t power of 2 over 2 minus t, right? This is from 1 until x. So we will get, if we do a calculation, we will get x power of 2 over 8 minus x over 4 plus 1.1 over 8. So this one should be x power of 2 over 8 minus x over 4 plus 1 over 8. This is from x is between 1 and 3, right? For the second part is fx, we will do the same step, which is 1 until 3. This is t minus 1 over 4 with respect to t plus, and the second one is 5 until x, which is 7 minus t over 4 with respect to t. So if you do a simplification, we do integration, let me take out the 1 over 4 outside. So 1 over 4, and we do integration here, so be t over 2 over t power of 2 over 2 minus 1 over 2. Right, so to integrate this one, all right, what we need to do is, so this one is t squared over 8, right, minus t over 4. This is from 1 until 3. And the second part is 7t over 4 minus t squared over 8. This is from 5 to x. So this one should be 9 over 8 minus 3 over 4. This is for the first part. This, and the second one is 1 over 8 minus 1 over 4, right? So this is for the second part. So plus, this is 7x divided by 4 minus x squared over 8. This is the first part, minus The second part is 35 over 4 minus 25 over 8. So this is for the second part. So let's solve for this one. So this one should be 9 minus 8, 9 over 8 minus 1 over 8. Right, and then negative 3 over 4 plus 1 over 4 for the first part. And then the second part is okay, this is 7x over 4 minus x squared over 8, and then this one is 35 over 4 plus 25 over 8. Right, so let's solve for the first one. So this one should be 8 over 8 minus this is negative 3 plus 1 is 2 over 4. So this one should be how much? This one should be 1 minus 1 over 2 is equal to 1 over 2, right? So this one should be 7x over 4 minus x squared over 8, and 35 over 4, right? 35 over 4, let me put into calculator. Negative 35 over 4 plus 25 over 8. So this one should be negative 45 over 8. So let me plus with 1 over 2 plus with 1 over 2. It should be equal to 41 over 8. So this is 7x over 4 minus x squared over 8 minus 41 over 8. So we just need to plug into the formula. This one should be 7x plus minus 7x over 4. 7x over 4 minus x squared over 8 minus 41 over 8. For x is between 5 and 7. I think I may do a mistake here in calculation. So I think you can do a rechecking again and confirm back with me whether the answer is correct or not. So I think that's all for continuous discrete continuous random variable, means continuous probability distribution function, and we will continue on a special continuous probability distribution function next class. Right, I think that's all. Thank you very much. Assalamu